Today on Engine Power, Ford fans, strap in because we have a big bore small block bullet coming your way.
We set the tone for a high-powered build with proper prep, precision machining, and a show-quality paint job. All right, everyone. It is Ford Day in Engine Power. We are kicking off a brand new build for you Ford fans. I know we've been doing a lot of Chevy stuff, but today we are going to build an awesome short deck, big inch, small block Ford, and we have a bunch of great parts that are right out of the catalog. So this is going to be one of those builds that if you need a really cool small block Ford build for your project, you can go ahead and copy this, follow along, put it together just like us, and have a ripper of an engine at the end. So kicking it off, we have one of Summit Racing Equipment's aftermarket SPC Street Performance or Competition engine blocks. So this is their 8.2 deck small block Ford version. So this is based around the 302. You can get it in a 4-inch bore or a 4.125 bore, which is what this one is, and you can take it all the way out to 4.165 bore easily. So this is a really great foundation. It does use the 7/16 head bolt holes like a stock 302. It has provisions in the lifter valley for the stock factory rollers if you want to use those, or you can use a link bar, no problem. It has extra wall thickness around the cylinders. It has extra deck thickness for boosted applications if you want to do that. It uses the factory timing covers, factory cam setup. It does use the SVO style cam bearing, so you can get a good high quality aftermarket bearing. All the oil galleries are tapped in this thing, so it has easy serviceability. It's cast over in Germany out of a really high class grade of cast iron, and then it's brought over here and machined in the US in Kearney, Nebraska. So on the bottom end, we have a really robust architecture. We have 4-bolt mains on numbers 2, 3, and 4. So we have a 7/16 inner and a 3/8 outer, and then we have a 2-bolt main on the front and rear. That way you can get a pan to fit on the engine very easily without a bunch of modification. It has extended skirts for stroker builds, so you have a little bit more support on the piston skirt. And it has built-in stroke clearance for up to 3/400-inch stroke, which is really common on these short deck builds. So this is an awesome foundation. It's super robust. This block is rated for 700 horsepower, but so is our small block Chevy block, and we have pushed that one to over 1,200 horsepower. So this is not where the great parts stop. We have a ton of cool stuff going in this as well.
Like Frankie was saying, we live in exciting times where you can just order this stuff out of Summit Racing's catalog and bolt it together and make some big power. So first we're going to talk about the rotating assembly. We are starting off with an Eagle Specialties 4340 forged crankshaft. This is 3/400 stroke. It is going to be swinging around some of Eagle Specialties H-beam rods. These have a 927 small end, a H-beam design with an ARP 2000 rod bolt. That's an upgraded bolt because we're going to be spinning this thing a few RPM. They are going to be swinging around some DSS FX series pistons. Now these are pretty cool. They are 1090 compression height, so they'll fit in our deck. These have a 1.2, 1.23 millimeter ring pack and a 927 pin. These are built out of 2618 alloy, so they're going to last for what we are doing. Now, if that wasn't cool enough, it's really going to get exciting on the induction side because we are going to be using for a cylinder head the brand new Trick Flow Twisted Wedge 11R. Now, these are 227 cc on the intake side, and these flow mad air. On Trick Flow's bench, these flow 342 CFM at 650 lift. Moving on to the camshaft, we're going to be using one of Summit Racing's Pro SBFs. They have a lot of cool lines for camshafts that they've developed on all different types of platforms. This is their small block Ford version. This is a steel billet cam that is a hydraulic roller with durations at 50 thousandths of 242 on the intake, 256 on the exhaust, and this particular one is set at 110.5 degrees of lobe separation angle. Complementing our camshaft, we'll be using a set of Comp Evolution retrofit lifters. With our lift, we are going to be using a 1.7 rocker. It's an Ultra Pro Magnum from Comp. So our net lift with this setup is going to be 624 thousandths on both the intake and exhaust. Now to get all that air through those intake ports on the top side, we're going to be using one of Trick Flow's R-Series manifolds. And the cool thing about this one, the ports have been CNC matched to our cylinder head. So this thing is a sweet setup. Now all this is going to go on eventually, but you know the drill. First off, we have to get the block prepped. The nice thing, most of the machine work has already been done to the block. So all we really have to do is deburr it and hone it. But the deburring comes first, and that's what's coming next.
In a moment, it's nose to the grindstone as we soften edges and set surface finish.
In today's Summit Tech Tip, we're going to talk all about cam bearings. cam bearings are just as important as main and rod bearings, but sometimes they get overlooked. Bearings nowadays are much better than their OE counterparts from yesteryear because they are made out of better materials and they come in different designs that help stock engines run better. The stock bearings sometimes were made in one piece and they were layered together and hooked together in like a little puzzle piece. These are now one-piece bearings. They're much better than the stock bearings, and they come in different varieties like two-hole with a groove, but they are directly replacing the old cam bearings. On the performance side, the bearings are made out of better material and they have coatings in them that will help handle all of that big spring pressure. And sometimes the bearings will have an annulus on the outside so oil can flow all the way around and it goes in onto the camshaft every 120 degrees. These types of bearings are usually in race engines, but sometimes OEMs have them too. Now, if you have any questions on what bearing to use in your particular application, you can contact the experts at Summit Racing Equipment.
All right, first thing we are gonna do, and you should do this on any new block, is we're gonna take the main caps off and we're gonna go ahead and deburr the parting lines. This is really important because when that main bore is machined, it can leave a little burr right here at the parting line on the cap. And if you don't remove that right when you take it off, that edge can actually get rolled under and it can go between the mating surface on the cap and the block. And this not only gives you an improper seating of the cap, but could potentially give you an inaccurate oil clearance as well. So the first thing we're gonna do is we're gonna take a little file and knock that off. We're gonna get all these off and go through and do them. Using a small hand file, you don't have to get crazy, we're just trying to break that sharp edge. While we're at it, we'll also go ahead and deburr any fine edges on the caps to clean up all the machine surfaces. We'll repeat the process on the main registers, carefully breaking the sharp edges but not removing a ton of material.
Then we'll switch over to an air-powered grinder with a carbide to deburr any sharp edges on the less critical areas of the block. The key here is to go slowly. Don't apply a lot of pressure. Let the tool do the work because the last thing you want to do is slip up and put a big gash in your new block.
After changing out the tooling, the next step we like to do is mildly port the oil passageways to improve oil flow. Using a variety of burrs, we will round off any abrupt turns in the path of the oil, like the oil filter housing that can cause turbulence and restrict oil flow. An abrasive cartridge roll is used to smooth out any imperfections and give the desired surface finish for a beautiful finished product.
We will continue this process following the path of the oil flow and even rounding off the oil drain backs for improved circulation. When we're finished, it will go into the Safety Clean jet washer for a quick stint to knock off all of that swarf that we put into the engine. Now that we are out of the cleaner and all cooled down, the next order of operations, which is our final machining operation, is to get the cylinders final sized for our DSS piston. This is a 2618 alloy, so we're gonna have a specific clearance we wanna set up, and that is a final bore size of 4-inch 125. Now, the first thing we're gonna do is we're gonna put the caps on the block. Not only does that give us a place the bar can go through to hold it into our Sun and SV15, it is important to have the caps on and torqued to spec. That recreates the lower cylinder distortion just like it was when it is assembled, and that is important to keep the cylinders round and straight. Some high pressure lube is added to the main fasteners and the inners are torqued to 75 pound-feet while the outers are torqued to 35 pound-feet. The block can be taken off the stand, lifted into the hone, and set into position before being clamped down. The exact same head gasket we'll be using for the build is then snapped into place. All right, now it's time to put on our torque plate. Now this is a steel torque plate and it has the proper bore size for our engine. This is a big bore 4-125 bore, so we have the proper plate for it. Couple of things to remember. Torque plates are important to recreate the cylinder distortion of what happens when the cylinder head is torqued on. Another thing, it is important for the torque plate to use the same bolts that we're gonna be using to bolt the head on. This is the same length protruding out of the torque plate that it does out of the cylinder head because it has to recreate that distortion the same way. So we're just gonna get her bolted on, get her torqued up. We borrowed this big bore torque plate from our buddies at Shacklet Automotive Machine, and it is held down with our set of ARP head bolts.
Using 150 grit diamond abrasive, it doesn't take long to remove the 5/1000ths left in the bore, but we will check our work periodically to maintain the precision geometry that it came with. All the bores are roughed out to within 2/10 of final size, and then they are finished with a 600 grit diamond abrasive to set the proper surface profile. After being rigorously cleaned, we can verify our surface finish with our profilometer and TraceBoss software. For this pump gas NA street application, these numbers are on the money, and this block can be final clean.
Coming up, we spin up the rotating assembly to match its components and set clearances for big power.
Okay, it's time to talk balancing because that's going to be the next machining process that we tackle on our 363, and basically is going to be the last one before we can start measuring up clearances and get to assembly. So the important thing with balancing, even if you're not going to be balancing your own crank, you need to understand what the process is and what you need to take to the machine shop with you. So we have everything laid out basically that's going to be hooked to the crankshaft so we can simulate that weight when it gets in the balancer. So starting out, we have our crankshaft, which this one is an internal balance crankshaft, so we don't need the flywheel or the damper. But if you did have an external balance crankshaft, you want to make sure you take those components with you when you go to the machine shop. We have our H-beam 5400 long rods. We have the rod bearings that we're going to be using in those rods. We have our DSS Racing twisted wedge pistons going to be hooked to them. And this is a relatively light unit. We have the locks that are going to go with these pistons. These are a quadruple true lock, which is basically kind of think like a snap ring, but very, very precise. And there's 4 per piston, so we want to make sure we get those. And we have the support rail that goes with our pistons because we have that short pin height and it does intrude into the oil control ring pack. And we do have the ring pack we're going to be running because all this stuff, even though it does seem very small, adds weight, and we want to make sure we account for that. So we're going to measure every component individually. We're going to take that average and we're going to build bob weights to simulate these when it gets in the balancer.
The cool thing about our CWT Industries crank balancing system is the scale is directly tied in and will automatically fill out the bob weight card with each component's weight and generate our average bob weight. In this case, it's a relatively light 1,740 grams, so we will assemble 1 bob weight per crank throw that is within 0.5 grams of that target. Each assembly is installed on the rod journals and centered with CWT's alignment tool.
All right, that is actually pretty good. 2.241 ounce inch on the rear, 1.2 ounce inch on the front. Looks like our rear is right on the corner of the counterweight, so we might have to do a little cutting there, but not a big deal. And our front one is right on the counterweight, so we could just put a hole there. So should be pretty easy to tackle. Let's get to it. This might seem overly aggressive, but it's actually the most effective and clean way to remove the weight in this part of the crankshaft. A coarse flap disc quickly cleans up our cut and gives us a professional looking finish. We'll do a couple of rounds of this, checking the imbalance as we go in order to sneak up on our tolerance. On the front side, an easy and shallow 5/8 hole quickly removes the weight, and we can spin it again. Ooh, okay, there we go. So we are at 0.102 ounce inch on the rear, and then 0.121 ounce inch on the front, 188 degrees apart from each other. And this is a great example of why you need to have your new components balanced, because if we go to our print screen here, the CWT balancer will actually calculate the amount of force that this crank would have had before and what it has now. At 7,000 RPM, this would have had 194 pounds of force on it, and now we've minimized that down to just 8.9 pounds. So definitely something that you need to get done. You need to balance your new components. You can't just throw them in your engine or you're gonna start destroying stuff. So we got this wrapped up. We'll get all our bob weights off. We'll get it polished up, cleaned up, then we can start checking main bearing clearances.
All right, our block has been final cleaned, ready for assembly. So the next thing we're gonna do is set our vertical oil clearance on the mains. Now you've seen us do this before. So first things first, we'll get the rest of the main bearings in the block. We'll install all the upper bearing shells into the block, but we'll install only the number 5 cap and the other bearing half for our initial measurement. Everything is put together just like final assembly, fully cleaned, dry, and torqued. A 2 to 3 inch micrometer is set to the rearmost journal size, and then we will use that to zero our precision dial bore gauge. That's a little tight. We're at 1/6. Now that is too tight, so what we would like to have is at least 1/1000th per inch of shaft diameter for our oil clearance. Now with a standard set of bearings, we cannot get there, but to get that out to where we need to be, we need a set of bearings that has a 1/1000th bigger on the idea, and fortunately, we have a set of those. So what we're talking about is a set of bearings that have 1/1000th extra clearance. What happens is we can use either a combination of X bearings and standard bearings or completely X bearings to get the clearance we want. For this application, we will use both extra clearance halves, and after swapping them out, put everything back together again and recheck our measurements before continuing to the rest. .26, 2.7. Dead on, thousandths over, so success.
Later on Engine Power, we go through our final checks before beautifying this blue oval in the paint booth. Okay, with all of our main bearing clearances set, we're gonna move on to the oil clearances for our connecting rods, and the process is very, very similar. First thing we gotta do is clean out all the bearing saddles in the rods and wipe down the bearings themselves with some kind of lacquer thinner or brake clean, and then make sure we get rid of all of the little dust bunnies or any lint in there. Then we're gonna load up our bearings. We're gonna start with a standard bearing set and go from there. We're gonna see what those do first. If we need extra clearance bearings like our mains, we have some. We're gonna start with these and then move forward. On narrowed rod bearings, there are an upper and a lower, and they're marked on the back with a U and an L. So the upper we will put into the rod side itself, and then the lower will go into our cap here. Get the dowel seated, start the bolts by hand. And then we want them to be a little bit loose so we can get a base measurement for our stretch. So we have our ARP digital stretch gauge. We're gonna start with no load on the bolts and not tight at all. Zero it out for this one. Check our other side. Lucky, also zero, so we got zeroed out for both. And then we'll stick it in our vise and tighten it down. Now with the bolts torqued, we'll recheck our stretch. So we're shooting for between 64 and 66 10,000ths. So we got 65 there. On this side, we got 64, so that's right in there. Now we can check our clearance. And then we'll use our 2 to 3 micrometer to measure the number 2 journal, because that's the rod we're looking at right now, which on a small block Ford is on the second throw. Use our micrometer to zero out our dial bore gauge, so it is set to the journal size. Lock that down, and we're good to measure. So that looks like 2.4. So what we're looking for as a minimum is 1/1000th per inch of shaft. So 2.1, we're at 2.4, so we're good to go. The remaining rods are checked for clearance, and they all fall between 23 and 25 10,000ths of an inch. All right, we have our 363 down here in the paint booth because it is time to lay some color on this thing. That's the last step before we can move on to assembly. So we have everything cleaned, taped off, prepped, and ready to go. We're gonna get these mixed up, start spraying. As a base, we are using P.O.R. black rust preventive coating, thinned very slightly to spray out of an HVLP gun. This not only provides corrosion resistance, but also improves adhesion and gives us a solid base coat. One medium coating is followed by a few heavy coats for proper coverage.
For this application, the project calls for a murdered out, fully black engine, so some gloss black engine enamel is reduced down for spraying and is loaded up into the same gun. With the base coat fully tacked up, we can put down one medium coat and then one heavy coat of engine enamel for a super smooth, super glossy black finish that you can just sink into.
All right, everything's out of the paint booth back here in the shop, untaped, looks beautiful. We're gonna go ahead and let this cure a little bit, but we got a bunch done today. Clearances are checked, parts are clean. We are ready to go together.
Yeah, so the next time you see this, we're gonna click it together, get it ran up on the dyno, and we may even show you what this is slated for. So make sure you tune in to Engine Power.
Are you a fan of Power Nation? If so, we got a brand new show for you to check out. Blacktop Speed Shop.
Subscribe to the Power Nation YouTube channel so you never miss a new episode.
110, baby, 110. It's time to load up so we can get to work.